we find that it is made up of protons, neutrons, and electrons, and a lot of empty space. Imagine an Olympic swimming pool, 50 meters wide. This is our atom. At the center of our atom is the nucleus. The nucleus is made up of protons and neutrons. But if we jumped into the pool to find the nucleus, it would be pretty much impossible, because it is the size of a grain of sand. Around the nucleus, we find that electrons are randomly whizzing around. The electrons are even smaller than protons and neutrons. So say we only have 2 electrons in our atom. These would be randomly moving around our grain of sand in our 50-meter pool, just these 2 tiny electrons. So what does that leave? A lot of empty space. Now if we think about the minuscule scale that we're talking about, the constituents of an atom must have a minuscule scale to match. If we were to weigh protons, we would need 600 sextillion to just weigh 1 gram. So 1 proton would have a very, very small mass, and the same is true for neutrons and electrons. This is why we weigh them in relation to each other. We assign the mass of a proton as 1. The neutron has a similar mass to protons and is also given the mass of 1. The electron, however, is much lighter and has a mass of 1/1840. If we think about how heavy the mass of the protons and neutrons are in relation to the electrons, it's clear to see that the mass of an atom is concentrated at the nucleus. Protons, neutrons, and electrons also have a charge associated with them. Protons are positive, neutrons are neutral, and electrons are negative. The charge of an atom is always neutral. This means there must be the same amount of protons as there are electrons in an atom. The number of neutrons can vary, and they do not affect the charge of the entire atom.